Hi children, how are you all? Hope you all are fine. Okay, I have seen your homeworks. I think you are doing your assignments also. Yeah, very good. Many students have submitted. Really happy of you. Okay, take your own time and do the assignment. Okay, and you have to submit your homework daily. Okay, the 10 one words you have to submit it whenever the class is there. Okay, assignment you can take 2 or more days. Okay, and you have to write in a A4 sheet and place it in a file. Okay, while we will tell, you have to come to school and you have to submit the assignments and class works. Okay. Okay children, and in previous class what we have taught you, what you have seen? Metallurgy. Yes, yeah, in metallurgy we have seen the types. Okay, metallurgical process, the first part we have seen concentration of ore, the removal of impurities, okay, the first part concentration of ore we have studied, isn't it? Yes. Okay, now today we are going to see about the second point, extraction of crude metal. We are going to see about the extraction of crude metal. Okay, let's start the lesson. Okay children, everyone are ready? Take your book, take your note, take your pencil with you. Okay, be ready. Okay. Now, what is extraction of crude metal? Okay, extractions of metals. Okay, I already told that only some unreactive metals such as gold, silver, platinum can occur freely in nature, isn't it? Some unreactive metals, they are native in nature, they doesn't react with other metals. Okay, that unreactive metals such as silver, gold, platinum, etc. can occur freely in nature. Okay, but most metals reacts with other elements to form ores. Okay, most metals reacts with other elements. Okay, some metals only unreactive, some metals only remain same, but many metals react with other elements and form another metal. Okay, right? Do you understand? Now, what is extraction of metals? Extraction of crude metal from the concentration ore. Now, concentration of ore is completed. Okay, what is concentration of ore? Removal of impurities. Now, that removal of impurities is completed. The 4 headings. Okay, what is that? First one, gravity separation method, removing the impurities by water. And second one is, what is the second one? Do you remember it? Do you remember? Froth flotation. Okay, by using oil, by using a sodium ethyl xanthite. Okay, that components we are removing the impurities again. Okay, then what are you doing? Leaching. Then what are you doing? Leaching. Okay, it is also a process to remove the insoluble impurities. Okay, and further we are doing magnetic separation. This 4 method we are removing the impurities. We are removing the impurities. Now, extraction of crude metal. Extraction of crude metal from concentration ore. Okay, what is extraction? That is reduction. Okay. Okay, it is involving, okay, the extraction of crude metals from the concentrated ore is carried out into 2 steps, 2 major steps. Okay, first one is conversion of the ore into oxides of the metal, conversion of that ore into oxide, conversion of that ore into oxides, and further reduction of the metal oxide, reduction of metal oxide to metal. Do you understood? 2 processes carried out in extraction. The first process is, okay, ஒரு மெட்டல் இருக்கு. Okay, அந்த மெட்டலை என்ன பண்ணுறோம் அப்படின்னா கன்வெர்ட் பண்ணி ஆக்சைடுக்கு கன்வெர்ட் பண்ணுறோம். Metal of their oxide. If see there is a lead blend or zinc blend, you have to convert it to reduction process. Okay, so oxygen, with oxygen you are converted into oxides, lead oxide. further lead oxide is converted to lead. Lead oxide is converted to lead. So, first of all, converting that ore into oxide and reduction of that metal oxide to metal. Reduction of metal oxide to metal. Do you understood? In the concentrated ore, the metal exists in positive oxidation state. Hence, it is to be reduced to an elemental state. Okay. We can infer from the principles of thermodynamics. Okay. It is based upon the principle of thermodynamics. Okay. First, the ore is converted to the oxide of metal interest. Okay. First, let's see about the conversion of ore into oxides. Now, what is conversion of ores? Okay. Conversion of ores into oxides, already told there are two steps in extraction, conversion of ore into oxides and reduction. Okay. Do you understood? Right. In first of all, conversion of ore into oxide, there are further two steps, that is roasting and calcination. In conversion of ores to oxide, there are two steps, that is roasting and calcination. Two processes are undergoing here. Okay, roasting and calcination. Okay, do we understood? Roasting. First of all, we are going to see about roasting. It is a method. Okay, it is a method used for conversion of sulfide ore. Conversion of sulfide ores into their oxide. Conversion of sulfide ore into oxide. Removal of conversion of sulfide ore into oxide. Do you understood? Roasting is a method. Okay, it is a roasting is a method applied for the conversion of sulfide ore into the oxide. Okay, in this method, the concentrated ore is oxidized by heating. Now, you have to heat by, you have to oxidize it. Okay, you have to oxidize the concentrated ore by heating with excess of oxygen. Okay, excess of oxygen in a suitable furnace. Okay, below the melting point of the metal. Okay, each and every metal has a suitable melting point. Okay, இப்போ lead எடுத்துக்கிட்டோம் அல்லது zinc எடுத்துக்கிட்டோம் அப்படின்னா அதுக்கு ஒரு melting point இருக்கு. ஓகே, அந்த melting point விட கம்மி டெம்பரேச்சர் நம்ம வைக்கிறோம். அந்த melting point வச்சோம் அப்படின்னா மெட்டல் மெல்ட் ஆகிரும். ஸோ அந்த melting point விட கம்மியான ஒரு டெம்பரேச்சரில் நம்ம இப்போ என்ன பண்ண போகிறோம், ஹீட் பண்ண போகிறோம். பை கிவிங் எக்ஸஸ் ஆஃப் ஆக்சிஜன், அதிகமான ஆக்சிஜனை விட்டு நல்லா ஹீட் பண்ண போகிறோம். ஸோ அப்போ தான் என்ன நடக்கும், ஒரு கன்வர்ஷன் அங்கே நடக்க போகுது. என்ன, roasting means conversion of sulfide ore. Sulfide related ores ஃபுல்லாக கன்வெர்ட் பண்ணுறது தான் roasting. Conversion of sulfide ores. Sulfide ores. Okay. See the example. See the example. 2 PbS. Pb means lead and S means sulfide. Oh, okay. Otherwise you can tell lead blend. Okay. ZnS means zinc blend. Okay. Okay, let us tell lead sulfide. Okay, lead sulfide plus oxygen 3O2. Oxygen 3O2. Okay, lead sulfide plus oxygen. Okay, in a furnace you are taking the ore lead sulfide and you are heating. Okay, the symbol triangle denotes heating. Okay, with excess oxygen you are heating. Now you will get lead oxide 2 PbO, that is lead oxide, and sulfur dioxide. Okay, sulfur oxides are gone away in gases. That symbol denotes symbol for gases, went away in gases. Okay, in this way zinc blend and copper sulfide are done. Okay, the sulfide ores are heated with excess oxygen in the presence of melting point which is below the melting point of the metal. Below the melting point of the metal we are heating with excess oxygen to the sulfide ores. We will get the oxides of that ores, oxides of that ore, that is lead oxide, zinc oxide and cuprous oxide. Like that we are getting the oxides of the ore and the sulfate gases are went away. This is the roasting method. Now calcination. Okay, what is calcination? Calcination is the process in which the concentrated ore is strongly heated in the absence of air. Calcination is the process in which concentrated ore is strongly heated in the absence of air. Okay. In the previous roasting, we are applying heavier what? Oxygen, okay, but here the air is absent, okay. Heating is done in the absence of air. So, during this process, the water of crystallization present in the hydrated oxide escapes as moisture, okay, escapes as moisture. So, any organic matter also get expelled, leaving behind a porous ore, okay. This method can be carried out with the limited supply of air. So, during calcination of carbonate ore, carbon dioxide is expelled. Okay. In the previous one, what happens? Roasting improves impurities such as arsenic, sulfur, phosphorus by converting them into volatile oxides. Okay. That sulfide gases are expelled. Here carbon dioxide gases are expelled. So, in previous one sulfur dioxide is expelled. I will tell one thing, that the sulfur dioxide which is produced during roasting process is very harmful. Okay. So, in modern metallurgical factories, this byproduct is trapped and converted to sulfuric acid to avoid the air pollution. Okay. Do you understood? The sulfur dioxide which is expelled, okay, which is produced during that roasting process, no, that is very harmful to the environment. So, that sulfur dioxide gases are trapped, okay, and it is converted to sulfuric acid, to avoid the air pollution, Do you understood, children? Okay. Now, see the example. Here we are taking carbonate ores. So, calcination process we are using for carbonate ores. Okay. In roasting you have taken sulfur ores. Okay. We also can take an arsenic and phosphorus also. Okay. But mainly roasting is done for sulfide ores. Calcination taken for carbonate ores. Okay. Do you understood? And during that calcination of hydrated ore, water of hydration is evaporated. Okay. Water of hydration is expelled as a vapor. Aviya veli poirudhu. Okay. Right. Now, example C, lead carbonate, calcium carbonate, zinc carbonate, magnesium carbonate, like that we are having the examples. Okay. See the first one, lead carbonate we are heating, okay, with the limited supply of air. Air is very simple amount, very light amount of air, okay. But in previous one we are taking lot of oxygens, but here we are not taking the oxygen, only we are taking the ore, lead carbonate, which is heated. The triangle symbol indicates heating, okay. Lead carbonate is heated. Now, what happens? Lead oxide plus carbon dioxide, it is separated as lead oxide and carbon dioxide. Next, calcium carbonate is heated and calcium oxide and carbon dioxide. Zinc carbonate gives, while heating, zinc oxide plus carbon dioxide. Do you understood, children? Right. Now, reduction of metal oxides. Okay. Now, metal oxide can be reduced to crude metal. Metal oxide can be reduced to crude metal by using a suitable reducing agent. First point, what is that? Conversion of ore into oxide, and the second one is reduction. Reduction of metal oxides to element metals. Okay. In that reduction, there are two methods. Okay. We will see about it. Smelting, more than two methods: smelting, reduction by carbon, reduction by hydrogen, reduction by metal, and also auto reduction. There are five methods in reduction of metal oxides. Okay. Metal oxides can be reduced to a crude metal by using a suitable reducing agent such as carbon, carbon monoxide, hydrogen, aluminium and such metals such as sodium etc. reactive metals. Okay. The choice of reducing agents depends on the nature of the metal. Okay. The choice of reducing agents depends upon the nature of the metal. Okay. We have to choose a reducing agent. Okay. In this reduction, we have to choose a reducing agent. Okay. Do you understood? We have to take a reducing agent. The choice of reducing agent depends upon the nature of the metal. Okay. By the nature of the metal, we have to choose the reducing agent. For example, carbon cannot be used as a reducing agent for reactive metals such as sodium, potassium, aluminium. Do you understood? If it is a reactive metal, we cannot use carbon. Okay. Already told that carbon, carbon dioxide, okay, carbon, carbon monoxide, carbon, carbon monoxide, hydrogen, aluminium, okay, they are taken as a reducing agent. But for reactive metals like sodium, aluminium, potassium, okay, we cannot use carbon as a reducing agent. Okay. Similarly, carbon monoxide cannot be used to reduce oxides such as zinc oxide, aluminium oxide. Okay. For reducing the zinc oxide and aluminium oxide, we cannot use carbon monoxide. Okay. This will be explained in the Ellingham diagram. Okay. That is a diagram called Ellingham diagram. In this diagram, we can study about the selection of suitable reducing agent. Okay. I will tell you for which metal, which reducing agent we have to use. Okay. We will see this in the further classes. Okay. In the next class, I think I will tell you about the Ellingham diagram. Okay. Now, what is smelting? What is smelting? Okay. In this method, okay, in this method, we are taking a flux and a reducing agent. What is a flux? Have you heard about a flux? A flux is a chemical substance that forms an easily fusible slag with gangue. Chemical substance that forms an easily fusible slag with gangue. Okay. It is fusible. Fusible slag. It forms a fusible slag with gangue. Okay. And a reducing agent such as carbon, carbon monoxide or aluminium is added to the concentrated ore. Okay. We are taking a flux and a reducing agent. The flux is carbon, carbon monoxide or aluminium is added to the concentrated ore and the mixture is now melted. Mixture is now melted by heating. How the melting is done? It is done by heating. So, at an evaporated temperature above the melting point of the metal, above the melting point, because the mixture should be melted. Okay, melted now. So, we have to give the melting point above. So, more melting point will melt the metal. Okay, in a smelting furnace. Okay, in the smelting furnace. Okay, see the example. Fe2O3 and is in a solid form plus carbon monoxide as a reducing agent. Here the reducing agent is carbon monoxide. We will get a ion Fe. We are getting a ion. That is a metal. Okay. Metal oxide can be reduced to a crude metal. In this process, what happened? In previous process, what happened? In extraction of crude metal, the sulfide ores are converted to metal oxides. Now, the metal oxides are converted to a metal, isn't it? In smelting process, Fe2O3, it is a oxide, okay? It is a oxide metal oxide, which reacted with the, what happens? Which reacted with the CO, that is a carbon monoxide, which is a reducing agent. When a metal oxide reacts with the reducing agent, we will get a metal. We will get a metal. Okay. We have got metal ion. Fe. Ion is a crude metal. We have got a crude metal. Okay. This is the example. Okay. In this extraction, a basic flux, a limestone, okay, is also used. Flux and limestone is also used to get a pure metal. Okay. In the extraction of copper pyrites, In the extraction of copper pyrites also, the concentrated ore is heated in a furnace after mixing with silica or acidic flux also. The ferrous oxide is formed by melting in a basic nature and combines with silica to form a ferrous silicate. Now the remaining metal sulfides are mutually soluble and form a copper metal. Okay, like that it is used in copper, iron, okay, flux, gangue, slag. In everything this process is used. Okay, already told now in this extraction we are taking a basic flux, a limestone CaO is also used, since the silica gangue, okay, silica gangue which is present in the ore, okay, in acidic nature, it combines, okay, it combines the limestone and form a calcium silicate. See the example, CaO, that is a limestone, react with silicate SiO2, that is a gangue, okay, that is a gangue which gives a slag, CaSiO3, that is a slag. So flux plus gangue gives a slag, flux plus gangue gives a slag. Okay, I also told that it is involved in the formation of extraction of copper from copper pyrites. Okay, extraction of copper, it is used in the extraction of copper from copper pyrites. Okay, copper pyrite is a basic ore and that ore is heated in a reverberator furnace with mixing with silica, acidic flux, then ferrous oxide is formed due to melting and it combines with silica to form a ferrous silicate, that is a slag, and further the remaining metal sulfides mutually soluble form a copper matte, and then the metal copper is solidified and its blistered appearance due to evolution of SO2, then we will get a copper. That copper is called blister copper. Okay, blister copper. Now reduction by carbon. Reduction by carbon. In this method, the oxide ore of the metal is mixed with coal. Oxide metal of the oxide ore of the metal is mixed with coal or coke. Okay, and it is strongly heated in a furnace. Okay, that furnace is called blast furnace. Okay, so this process can be applied to the metals which do not form carbides with carbon at a reduction temperature. This process can be applied to the metals which do not form carbides. This is only applicable to the, this process can be applied to the metals which do not form carbides with carbon at the reduction temperature. You understood? In this method, oxide ore of metal, for example, zinc oxide reacted with carbon mixed with coal, that is the carbon, okay, mixed with coke and heated strongly in a furnace. What happens? We will get zinc. We will get a zinc. So here what is the reducing agent? What is the reducing agent here? Carbon. Carbon is a reducing agent. See the example, manganese oxides reacted with carbon gives manganese. Okay. So oxides of a metal reacted with the reducing agent, we will get a metal, and that carbon monoxide or carbon dioxide gases are get expelled or evolved. Okay, this is the reduction by carbon. Have you understood, children? This is the process of smelting. Okay, further we will see by reduction reaction what happens. Now reduction by hydrogen. Okay, in this method it is applied to the oxides of metals such as iron, lead, copper, which is having less electropositive character than hydrogen. Okay, this method is only used for metals which is having less electropositive character than hydrogen. Okay, because the reduction is done by hydrogen. So metals which is having less electropositive character than hydrogen, okay, such as iron, lead and copper. Okay, so in that metals this method is applied. Okay, in that metals this method is applied. Okay, for example, nickel oxide can be reduced to nickel. Nickel oxide reduced to nickel by using a mixture of hydrogen and carbon monoxide. Okay, See here, here is an example Fe3O4 plus 4H2. Here hydrogen is used as a reducing agent. So reduction by hydrogen means hydrogen is used as a reducing agent. Reduction by carbon means reduction is done by carbon. So we are taking a metal oxide. What is a metal oxide? Fe means a metal, O4 or O3 or O2, that is a oxygen, no? So metal combined with oxides, that is metal oxide. So metal oxides reacts with metal, that is a hydrogen, react with hydrogen, it gives a pure metal ion. It gives a pure metal ion. See, 3Fe, it is in a solid form, and water in a liquid form. Okay, right? Do you understood? Now reduction by metals. Reduction done by metals. So metallic oxides such as Cr2O3, okay, can be reduced by an aluminothermite process. Aluminothermite process. Okay. In this process, the metal oxide mixed with aluminium powder. Metal oxide mixed with aluminium powder. Okay, and placed in a fire clay crucible. What is a fire clay crucible? Fire clay crucible. Okay, it is a furnace. Fire clay crucible is a furnace, like a blast furnace. Okay, it is a reverberative furnace, like that. It is a heating stove, like that. Okay, it is a furnace. Okay, now we are taking the metal oxide Cr2O3. Okay, Cr2O3, chromium oxide. Okay, that can be reduced by an aluminothermite process. That process is called aluminothermite. Okay, now we are taking chromium oxide. It can be reduced by an aluminothermite process. So this metal oxide, so chromium plus oxide, chromium is the metal, oxide is a oxygen format. So that is called metallic oxide. So that metallic oxides can be reduced. Here what we have to get? Chrome. Okay, we have to get chromium. Okay, so chromic oxide. Now what process is carried on here? This metal oxide is mixed with the aluminium powder, and placed in a fire clay crucible. To initiate the reduction process, ignition mixture is used, magnesium plus barium peroxide, okay, BaO plus MgO. Okay, magnesium and barium peroxide is used for this process. Okay, do you understood? For heating this, for heating or for reducing agent, as a reducing agent, BaO plus MgO is added. Okay, now you are heating the chromium oxide with aluminium Al. Okay, aluminium Al, and you will get chromium Cr. Now the reducing agent is BaO plus MgO and a metal called aluminium. Okay, you are using a metal. Okay, and you understood, children? Metallic oxides such as chromium 2O3 are reduced by a aluminothermite process. Okay, in this process the metal oxide is mixed with the aluminium powder and is placed in a fire clay crucible. To initiate a reduction, there is a mixture used, that is the magnesium and barium peroxide, BaO plus MgO, that is the reducing agent, and aluminium powder is also used. Okay, and Cr2O3 is taken. Okay, which forms a chromium metal. Now auto reduction. What is auto reduction? Do you have any guess? Auto reduction. Okay, I will tell. Simple roasting of some of the ores gives the crude metal. Okay, we are roasting the ores. Okay, what is roasting? Roasting means conversion of sulfide ores, isn't it? Conversion of sulfide ores. So in auto reduction, such cases, the use of reducing agent is not necessary. Okay, reducing agent is not necessary. Okay, for example, mercury is obtained by roasting of its ore Cinnabar. Okay, Cinnabar is HgS. Hg is mercury, S is sulfide. So roasting is applied for sulfide ores. Roasting is applied for sulfide ores. So mercury sulfide, HgS means mercury sulfide, which is called Cinnabar. So mercury sulfide is reduced by roasting process. So for converting the sulfide ore into a metal, we are using roasting process. So roasting means what? Oxygen, heating with the oxygen. Now HgS is reacted with oxygen. Roasting is going on, so involving oxygen in a gaseous form. Okay, we will give heating, and now the what we will get? Mercury as a liquid, mercury in a liquid form, and sulfur dioxide gas is expelled. Sulfur dioxide gas is expelled. This is the auto reduction. This is the auto reduction. The process roasting is carried on here because sulfide ore is present here. Do you understand, children? Yes. These are the extraction of crude metal. Let me tell what is extraction of crude metal. Extraction of crude metal is removing the oxides and getting a pure metal. That is the extraction of crude metal. Here two process involves. First of all, conversion of ore into oxides of metal. Conversion of ores into oxides of metal, and further reduction of that metal oxides to element metals. Okay, two process happens, and conversion of ore is further classified into roasting and calcination. In roasting, sulfide ores is taken and oxygen is applied, so high air is needed, and metal oxides are formed. In calcination process, carbonate ores are taken. Here air is not needed, so limited supply of air. Okay, so without oxygen, calcium carbonate or sodium carbonate, like that, it is heated and formed metal oxides. Lead oxide, like that, metal oxides are formed. So in conversion of ore into oxides, roasting and calcination process, we are getting the metal oxides. Now that metal oxides are reduced. Okay, now reduction of metal oxides into metal. So by smelting process, in smelting process we are using a reducing agent such as carbon monoxide, aluminum, like that. Okay, so you are using a reducing agent in smelting process. Further reduction is done by carbon. So carbon is acting as a reducing agent. Further reduction by hydrogen is used as a reducing agent. Further reduction by metal, so aluminum, potassium, like that, metal itself is used as for a reduction. Further auto reduction. In auto reduction, roasting process is used. Okay, roasting process is used. So auto means the same, done for it in the presence of, okay, in the absence of reducing agent. So we don't need the reducing reagents in this process. That is called auto reduction. That's all, children. These are about extraction of crude metal. Have you understood? Now it's time for your homework. Okay, it's time for your homework. Okay, write down 10 one words from this topic, extraction of crude metal. Extraction of crude metal. Okay, you can also write the equation as one words. Okay, as example, 2 PbS plus 3 O2 gives dash and dash. Okay, PbCO3 in the presence of heating, what gives? PbO plus CO2. Otherwise dash plus CO2, or heating happens or not, like that. Okay, you can also make one words from the what? Equations. Do you understood? Understood, children? Right. Okay, in the heading extraction of crude metal, there are 2 topics, and further in that topics it is classified into 2 and 5 topics. Okay, in these topics you take one words. Okay, and you are having assignment here. Okay, extraction of crude metal, this big question. Okay, you have to write what is extraction of crude metal, and you have to write the 2 most important steps in this one, and you have to write the steps involved here. Okay, conversion of ores, what steps are involved, and for reduction what steps are involved. Okay, you write two examples, two equation examples, okay. You are not need to write 3, 4 like that. Write two examples compulsory. Okay, this one question is your assignment. Okay, today your assignment is very less, no? I think you are feeling lot of works. Okay, today only one assignment I am giving. Next class we will give more assignments. Okay, right. Study well. Okay, from we have completed up to 2 headings in this chapter: concentration of ore and extraction of crude metal. Okay, rest of all we will see in the next class. Okay, okay children, do we understand? Are you having any doubts? Okay, ask me. Okay, thank you children.